Hi, I'd like to talk about one of the two ways that we can multiply vectors, what we call the dot product. And the dot product is called the dot product because we use a dot instead of a cross to denote multiplication, and the dot product is also called the scalar product because it gives us a scalar answer and the cross product gives us a vector answer. Well, say we have two vectors, A and vector B. What the dot product asks us is how much does vector A point in the same direction as vector B? Well, by a definition, A dot B is going to be the size of A times the size of vector B times the cosine of the angle between A and B. So if we take a look at our unit vectors I, j, k in Cartesian coordinates, I hat dot I hat, each unit vector is a size of 1 by definition, and the angle between the x-axis and itself is 0, so the cosine of 0 is 1. So for I dot j and I dot k, the other Cartesian axes are at a 90-degree angle to each other, so the dot products are going to be 0. Now, if I take j dot I or j dot k, again I get 0. But the y-axis, j hat dotted with itself, gives me 1. And k hat dotted with k hat also gives me 1. So if we're looking at the same axis logically is in the same direction as the same axis. An orthogonal axis, like in the Cartesian system, is not at the same direction as the other axis. And if we are looking at opposite directions, k hat dotted with negative k hat, we just get a value of -1. And we could imagine sort of distributing around that negative sign, commuting those two operators, and that is perfectly fine because the dot product, the scalar product, follows the rules of association. So A dot B is going to be the same as B dot A. So how could we calculate it differently if we don't know the magnitude of A or the magnitude of B or the angle between them? Well, we could take vector A written out in component form, AX in the I hat direction plus AY in the J hat direction plus AZ in the K hat direction, dot it with BX I hat plus BY J hat plus BZ K hat, and we end up getting 9 total terms. So our first term would be AX BX I hat dotted with I hat. Well, I hat dotted with I hat is just 1. So I get AX BX. Then AX BY I dot J is 0. So that goes away. I dot K, 0. J dot I, also 0. J dot K, 0. K dot I, 0. K dot J, 0. The diagonal components here of this distribution, AX BX, AY BY, AZ BZ, those are all going to be multiplied by 1. So we could also say that the dot product is equal to AX BX plus AY BY plus AZ BZ. So just a couple of other final fun uses for the dot product. How do you find the magnitude of a vector? Well, the magnitude of vector A is going to be the square root of the dot product of A with itself. A dot A gives me AX squared plus AY squared plus AZ squared. Take the square root, that gives you the size. If you need to find the angle between two vectors, but you know the components of those two vectors, well, if you know the components of the two vectors, you can calculate the dot product by components, divide by the magnitude of A, divide by the magnitude of B. That gives you the cosine of the angle between those two vectors. Thanks for watching.